Good morning, all. In today's class, we will be continuing with few more problems on Module 1. We have already covered few problems on Coulomb's law. We have seen how to calculate the vector force as well as the magnitude. If single charge is there, if two charges, if three charges, if four charges, like that, we have seen variety of problems. Then we have seen in the previous sessions how to find electric field intensity due to one charge, due to two charges, net field, how to calculate, and that one was the homework also. Mm. In today's session, let us discuss the problems based on the charge densities. Okay, the charge density. Just a second. Okay, in today's class, we will be discussing a few problems based on the charge densities. We have seen three different charge densities, that is rho L, rho S, and rho V. So linear charge, surface charge, and volume charge. So let's see a few problems based on these charge densities. Okay, let me just make the color different. Okay, this is the problem. A uniform line charge, that is, this problem is associated with line charge, okay, rho L, of linear charge density 25 nanocoulomb per meter. The unit is rho L is equal to charge divided by length. So coulomb per meter. It lies on the line x equal to -3, z equal to 4, and y equals to 0. This x, y, z, these points are given to position the line, how the line stands, either in this direction, in this direction, in this direction. Depending on these points, you have to mark and you have to see how the line looks, how the line lies. Okay, that is given in the free space. Means again epsilon should be taken as the what, the dielectric, the medium is air. We need to find the electric field intensity at some point. So till now we have seen the problems wherein charge is given to you, some point is given to you, and at some point you find the electric field. But in this problem, instead of a charge, instead of the charge q, rho L is given, collective, the distribution is uniform, collective, all together. Instead of single charge q, a line is given to you. You need to find the electric field intensity. Okay, that's the difference. Let us start the solution. Very first thing, you list out the given data, the very first thing. So rho L is given to you, linear charge density 25 nanocoulomb per meter. And what else is given? You can even list out these 3 points on which the the line is standing. That also you can list out, no problem. Then let us try to position this line in the coordinate system. For that, you can observe, I have drawn it here. This is a 3-dimensional coordinate system. This indicates x. This is your have I done it wrong? Y and Z. If I take, I think I have marked it Z here. Let's see. X equal to -3. So x -3 means in this direction, move -3. If I take this 1 unit, 2 unit, 3 unit, I will come somewhere here. Then Z equal to 4. So if I just move 1 unit, 2 unit, Z equal to 4, right? After this, 1 unit, 2 unit, and 4, somewhere here. Okay. Then y equals to 0. There is no movement in this direction. No. So somewhere here the line lies. The line I have drawn it. Okay, I hope you understood. First move 3 in a negative x direction, then move 4 in a z direction, positive z direction. No movement in this because sorry, you make this okay. Why? No movement, no traveling in y direction, because y equals to 0 it is given. So don't go for this, only this. So this line, this is your the position where your line is lying. Okay, this is first thing. Then what else? You need to point 2, 15 and 13. This is the point where E has to be found out. So let me position x equal to 2 distance. Okay, let me start this. X equal to 2, 1 unit, 2 unit. If I divide, Okay, somewhere or here I have pointed here. Okay, 2 units approximately you can take. Then y direction 15. So if I move from this y direction 15, it comes somewhere more, which comes after this. So what I'll do, somewhere here, I will assume that this is a big longer distance of 15. Okay, for time being, because otherwise this point comes here. So just to make easiness, let the point be positioned here, but otherwise if you travel 15 distance here, the point comes somewhere here. No issues. If you want, you can do that. Let it be. I have taken this point somewhere here 15, and after that 13 in z direction. So move 13. Again I have made it wrong. Make this 13. It is not 3, it is 13. So point somewhere here it will come. It is up to you to take the 15 unit somewhere here. If you take it very dimensionally, measurement wise, very accurate, point comes here, but I have not done that. So approximately let me put the point somewhere here. Okay, so this is the point where you need to find the electric field intensity. Now this is the line and rho l is given to you. You need to find the E at this position. Okay, we know the coordinates of this line also, -3, 0 and 4. It is already given, -3, 4 and 0. Now, this line on which the charges are residing, for that, what I will do, I will draw a perpendicular from the point P so that this coordinate I can find out, center point. Okay, from the P, if I draw a perpendicular, I will come here and let us try to find the coordinates of that center. Okay, this line is common. This line is -3, 0 and 4. So -3 is for time being you keep it 0 and 4, no doubt. But as it is parallel to this, parallel to point P, y direction will become 15. Okay, because point, I have just dragged a perpendicular on the line, but point P, it is having some y direction. So as the line, this point, it is coming parallel, so y distance will become 15. X and z will be from this line, -3 and 4, and y distance will be from this point. Okay, very important to mark this point. Let me repeat it. X and y, as the line is common. Okay, so this line will be having x as -3 and 4, same as that of this line. However, y point will be, as the point P is parallel to the line, so 15 will be the y direction point. Okay, we have marked this point now. Let's now continue finding the electric field intensity. We have already seen in the theory part what is the equation for electric field intensity E. That is rho L divided by, we have derived this equation, line charge, 2 pi epsilon naught into r, the distance, and the unit vector AR. This is the field. In that, rho L is already given to you, epsilon naught into epsilon r. Epsilon r is the air, that is equal to 1. Then distance and unit vectors you need to find out. Let's move. The distance will be, what I will do, I will simply go for this distance calculation. Okay, only x and z, not y, because anyhow if you make 15 minus 15 it will become 0. So only x and z coordinates you have to consider. You can even do that with this also. Check. Only this x and z. X and z. You should not consider y, because in the given question you don't have any point traveling towards y. So find this distance using the distance formula. 2 minus of -3, which will be 5, 5 square. 15 minus 15 will be 0. 3 minus 4 square, that is 1 square. So 5 square plus 1, root 26, right? So 2 minus of -3 square, 15 minus 15 will be 0, and 3 minus 4. Only x and z will exist. So root of 26 is the distance. This denominator we have found out. Let's go for this unit vector. Unit vector will be, let's see the direction. As all these line charges, we assume that all are positive, so the field lines will be diverging. So this is the direction. If you take the direction like this is your initial point, this is your final point. Make final minus initial. So what is final? It is this. Okay, initial is this. So 2 minus of minus 3, 15 minus 15, 3 minus 4. You have to take this for is AR. So take that 2 minus of minus 3 into AX. I have not written AY because 15 minus 15 it will go, and AZ is 3 minus 4 divided by the magnitude. Magnitude of the position vector is R, which we have already calculated, root 26, right? So AR is given by the position vector R divided by its magnitude. The position vector R divided by magnitude. So we have calculated, you can go for this calculation of this rho L given 2 pi epsilon naught into R into this unit vector AR. So calculate that, you will get AX and AY, sorry, AZ, two coordinates you will get. Further is simplification, you can do that. You will get somewhere 86.42 AX minus 17.28 AZ volt per meter. Okay. The only change is, instead of taking charge Q, we will take a rho L. So it is very important in order to get these two, the distance and the unit vector, how the line lies, whether in this direction, in this direction, in this direction. So that should be very important. So according to the given line, these points we have taken, line comes somewhere here. Okay. This is one problem. If the question is to find the magnitude, how will you take? Square root of this value square plus this value square. Coefficients you have to take, square them, add them, and square root of the answer. You will get 88.1 volt per meter. I hope you understood this problem. Any doubts, you can ask me here. What is that? 2 minus 3, 13 minus 4. Okay, fine, Anjum. I think your question is very much valid. So either I may be wrong somewhere. Probably the point must be a 3, if that is the case. You can take anything, because we are not very much bothered about what is your final answer. We are bothered about the procedure. Okay, आप इसको क्या करो, इसको 3 ले लो, क्योंकि मैं सभी कैलकुलेशंस 3 पे ही करी हूँ, राइट? अदरवाइज ऑल माय रिमेनिंग प्रॉब्लम विल गो रॉन्ग. सो बेटर यहीं पर चेंज कर दो, इसको 13 की जगह पर 3 कर दो, ये इजी रहेगा. ओके, इंस्टेड ऑफ 13 यू मेक दिस पॉइंट 3, तभी सभी सही रहेगा. मुझे पेपर में ज्यादा प्रॉब्लम नहीं होगा, क्यों नहीं तो फिर 13 माइनस 4 पूरा आंसर चेंज हो जाएगा, पूरा रॉन्ग हो जाएगा मेरा. ओके, 13 को 3 कर दो, दैट इज बेटर. ओके, okay, let me take one more problem of similar kind. Okay, question, there is a charge, we have to find the flux density. Okay, in the yesterday's session I have already discussed, instead of field, if question is to find D, what will you do? Okay, no doubt what all procedure we follow to find E should be done as it is. Last step would be D equals to epsilon naught into E. दिस इज द रिलेशन. जो भी हम फाइंड करे रहते हैं फील्ड को, उसको ये फॉर्मूला में डाल दो, आपको फ्लक्स आ जाएगा. सो क्वेश्चन में अगर फ्लक्स फाइंड आउट करना है तो नो डाउट आपको पहले फील्ड ही कैलकुलेट करना है, फील्ड के बाद ही आपको फ्लक्स डेंसिटी कैलकुलेट करना है. ओके, एक पॉइंट दिए हैं, द पॉइंट गिवन इज 6, 8 एंड -10. एट दिस पॉइंट यू हैव टू फाइंड द फील्ड एंड द फ्लक्स. ओके, there are some 2 to 3 sub questions. The third sub question I have scratched it, but no doubt the same thing I have already calculated. I will show you afterwards. First thing is, there is a charge द चार्ज इज 30 मिलीकुलम एंड इट इज केप्ट एट द ओरिजिन। इसका मतलब क्या है, एक 3 डायमेंशनल कोऑर्डिनेट सिस्टम है, यहाँ पर ओरिजिन पे एक चार्ज रखे हैं दैट इज 30 मिलीकुलम एंड P6 8 10, 6 is somewhere here, 8 is somewhere here, minus 10 is somewhere here. Okay, I will come somewhere here. This is your point P. So यहाँ पर आपको फील्ड एंड फ्लक्स कैलकुलेट करना है ड्यू टू द चार्ज Q. ये आपका फर्स्ट क्वेश्चन है. ओके, सिमिलरली सेकेंड क्वेश्चन क्या है, सब क्वेश्चन, there is a line charge and line charge density दिए हैं already, that is rho L is given and they have told you the position, indirectly they have specified you the position, line कैसे रखना है. Okay, that is on the z axis. Question में it is mentioned on the z axis. Fine, so let's move. फर्स्ट थिंग इज वी हैव टू, इट इज सिमिलर, अब तक हम ऑलरेडी ये ऐसे 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 प्रॉब्लम्स हम किए हैं, लेट अस रिपीट इट. देयर इज अ चार्ज, इफ द चार्ज इज केप्ट एट द ओरिजिन एंड एक पॉइंट है 6 8 minus 10. यहाँ पर आपको फाइंड करना है इलेक्ट्रिक फील्ड E एंड फ्लक्स डेंसिटी D. चार्ज पॉजिटिव है 13 मिलीकुलम. So direction of unit vector will be like this. This is your initial point. This is your final point. So final minus initial करना है आपको. What I have done here, directly मैंने calculate किया है D equals to epsilon naught into E. So epsilon cancel हो जाएंगे, Q by 4 pi r square इतना बच जाएगा. But no doubt आप क्या करो, you go for पहले field calculate करो, उसके बाद आप D equals to epsilon naught into E करो. आपको एनी हाउ मेरा जो आंसर आया है आपका भी आंसर सेम ही आएगा. ओके, वट एवर मेथड यू फॉलो. नाउ इन द फॉर्मूला इफ यू ऑब्जर्व, चार्ज ऑलरेडी दिए हैं, डिस्टेंस यू नीड टू कैलकुलेट एंड यूनिट वेक्टर यू हैव टू कैलकुलेट. व्हाट इज द डिस्टेंस, फॉर्मूला यूज करो, 0 minus 6 0 minus 8 0 minus of minus 10 whole square. Okay, square root of, you add them, you will get 14.14 meters. This is distance. Now similarly AR we need to calculate. What is AR? Unit vector. That's what I said. For calculation of AR, direction is important because Q positive है, diverging field रहेगा. So initial point, final point. So subtract final minus initial. 6 minus 0, 8 minus 0, minus 10 minus 0. That I have done. 6 minus 0 is 6, 8 minus 0 is 8, minus 10 minus 0 will be minus 10, divided by the magnitude of the R, 14.14. If you simplify it all together, you will get flux as this much. अगर आप वो मेथड फॉलो करोगे जहाँ पे पहले आप फील्ड कैलकुलेट करते हो, उसके बाद D equals to epsilon naught into E फॉर्मूला लेके आप अगर वैल्यू कैलकुलेट करेंगे, your answer and my answer should match. What all I have got directly D, it should match with your answer. Okay, now this is the first sub question we have calculated when charge is given to you. Next time second sub question check karo, linear charge is given on z axis. So let's see that. On z axis matlab aise rahega. Okay, on the z axis parallel to z axis. So line ऐसे रहेगा, not like this, not like this, nothing. On the z axis it looks like this. Okay, now this is your origin point. On the z axis means what, सिर्फ z value ही present है and बाकी के x and y जो हैं 0 0 हैं. Okay, the meaning is like that. This is not z equal to 0, it is simply z. X and y 0 0 है, only z axis exists. This is the coordinate. Now there is one point given to you. What is that point? In the question it is 6 8 and minus 10. So पहले उसको mark कर लो. 6, if I travel 6 somewhere here, 6 8 6 somewhere here I'll get, 8 somewhere here I'll get, 8 direction y and minus 10. So यहाँ पर कहीं आती हूँ मैं, यहाँ पे I will get the point somewhere here. So P of 6 8 and minus 10. यहाँ पे आपको field and flux density calculate करना है. This is the point and line यहाँ पे है. Now again, if I draw a perpendicular like this, no doubt x and y 0 0 हैं on this line. You can check. यहाँ पर no x coordinate, no y coordinate, only the z coordinate is existing. But what is the z coordinate? Point में check करो, z coordinate -10 है. So z coordinate -10 रहेगा. Obviously ये 0 point है. कितना ट्रैवल किए हो यहाँ पे? -10, राइट? तभी आप यहाँ पर रीच हुए हो, क्योंकि ये आप पहले 6 ट्रैवल किए, बाद में 8 ट्रैवल किए, बाद में नीचे आ गए हो -10. सो z कोऑर्डिनेट -10 है. So here the z coordinate is -10. This point and the line is parallel to each other. If I draw a perpendicular like this, x and y coordinates are 0 here at this point. However, z point, what is the distance from the origin to this point? This is your z direction, -10. So the point will be 0 0 and -10. Okay, I hope you got this. What are the points of this this point when we draw a perpendicular line? Then as usual we will go for what I have done. I have calculated D directly. You go for first calculation of E and then you go for flux density. Okay, D equals to rho L divided by 2 pi R. Rho L is already given in the question. You need to find the distance and the unit vector. Distance क्या होगा? Check करो. The distance will be, see, on the z axis बोल के दिए हैं. So only you consider this 6 minus 0 or 0 minus 6, then 0 minus 8 or 8 minus 0 whole square, then minus 10 minus plus 10 cancel हो जाएगा. So z term cancel हो गया. Okay, then only x and y coordinate रहेगा. Square root of 6 minus 0 whole square, 8 minus 0 whole square plus minus 10 plus 10. वो third term 0 रहेगा. So you will get 10 centimeters. 6 square plus 8 square, 64 plus 36, root 100, 10. The value of the distance is 10. Magnitude. So I have substituted that 10. We will get something here. And AR. So let us find AR. AR will be, you can check. It is again the same thing. To find AR, this positive charge है, point है. So diverging field रहेगा. Initial point, final point. Make final minus initial. 6 minus 0 into AX, 8 minus 0 into AY, minus 10, minus of minus 10. So minus 10 plus 10 into AZ, Z term will go. So 6 minus 0 AX, 8 minus 0 AY. ये numerator है. So denominator is the magnitude. Magnitude is 10, right? AR cap is given by the position vector R divided by its magnitude. So magnitude अभी calculate किए हैं, that is 10. Now further is simplification. This will become, what I have done, 6 by 10 0.6 ले ली हूँ, 8 by 10 0.8 ले ली हूँ. Okay, easy हो जाएगा calculation. Further is multiply these two and multiply these two. You will get the flux. I hope you understood this problem. Any doubts you can ask me. Okay, Asma, something she has messaged me, just a second. Okay. Fine. So any doubts in these two problems which I have solved? Any doubts you can ask me, or I'll continue with the next problem. Hope you understood. So let me take one more problem. It is again similar problem. I think you can do this. I'll just tell you how to do it. You can try. You need to find the electric field intensity at the origin. Origin पे charge है, that is 12 nanocoulomb. Sorry, we need to find the electric field intensity at the origin if charge is placed at 206. This is the first sub question, similar to the earlier problem. We can do this. There is a charge Q and it is 12 nanocoulomb, and that charge is at point 206 ये point है. Shall I show this on the coordinate system? That is better. 206 x direction में 2 travel करो, y direction no traveling because y equals to 0, and z direction 6 up 6. Somewhere here the charge q exists. This is point 2 comma 0 comma 6. Then what is the question? We need to find at the origin, that is 0 comma 0 comma 0 origin है. origin पे आपको field E calculate करना है. charge यहाँ पे है, field यहाँ पे calculate करना है. Okay, something like this. So I hope you can try this. I have done the same. 1 by 4 pi epsilon naught charge by distance square into AR. Distance I can calculate. What will be the distance? Origin and this. 0 minus 2, 0 minus 0, 0 minus 6 whole square. 0 minus 2, 0 minus 6, 0 minus 0 square, square root. Totally will be root of 40 you will get distance, and AR will be what? This is the position, this is the origin, point P, point O, origin. Q is something like this, diverging field, charge Q यहाँ पे है, positive charge है, so field will be diverging. This is your initial point, this is your final point. Make final minus initial. So final is 0, 0, 0, initial is 206. I have done the same. 0, 0, 0, 0 minus 2, 0 minus 6 and 0 minus 0. So AZ नहीं रहेगा, सिर्फ AX and AY. Divided by the magnitude. Magnitude just now we have calculated, it is root of 40. Further is simplification. Take this, you will get 0.8548526. Then multiply this with minus 6 divided by root 40. You will get 2.5576. This is the first sub question. The second part I can see. Second part is, if the session ends, please join back. I have one more problem. Second session, the second sub question is Royal. Linear charge density is given to you. It is 3 nanocoulomb, and the position is given how the line looks, where the line lies. X equal to 2, y equal to 3. Z direction नहीं है. Okay, so आपको Z count ही नहीं करना है. 2 and 3. So let us first try to position the linear charge. Line charge कहाँ पे place रहेगा? X equal to 2. X equal to 2, somewhere here I will get positive direction. Y equal to 3, positive direction में somewhere here. Z तो no movement, so somewhere here the line charge lies. यहाँ पर position है. This is one point. Now if I want to draw a perpendicular, point कहाँ पे है? Point is 206. So point somewhere here आएगा 206, right? So 2 y direction में कुछ नहीं है, 6 यहाँ पे. So this is your point P, 206. ये आपका line है. Line क्या है? 2, 3 and 0, right? X equal to 2, y equal to 3, z equal to 0. So ये आपका line charge का point है, ये आपका point जहाँ पे आपको field calculate करना है. ये दो चीजें हो गई. If you want to draw a perpendicular, what is this point? This point will be, if you observe, 2 and 3 will be same initially. Take it. 2 and 3 will be same. What is the z direction? In given position में z नहीं है, but point is parallel to this line, right? So that is 6. Add that. As well as you have x also 2. So 2 plus 2 will become 4. That is one thing. You have to remember, x you have traveled direction 2, and here also you have 2. So 2 plus 2, it will become 4, and 0, you no need to do. As the point is parallel to the line, z direction will become 6. Okay, this is the point. So once we do that, let's go for calculation. Rho L divided by 2 pi epsilon naught into R into AR. So distance is what? Calculate the distance. 2 minus 4, 0 minus 3, 6 minus 6. 2 minus 4, 0 minus 3, 6 minus 6, root of 13 you will get. And AR calculation, that is unit vector, check the direction. Direction will be something like this, right? So initial point minus final point. 2 minus 4, 0 minus 3, 6 minus 6. That's what I've done. 2 minus 4, 0 minus 3, 6 minus 6, AZ value nahi aayega, it is 0. Further is simple calculation. So जो भी formula है substitute करो values को, you will get the electric field intensity. ये problem में specifically you should remember how we got this point as 4. Okay, that is very important. Earlier what we did, x and z coordinate जैसा था वैसे रखे हैं. You just compare this problem with this. यहाँ पर चेक करो आप, ये पॉइंट तो सेम है, ये यहाँ पर एक्स वाई 0 0 है, z डायरेक्शन हम कर लिए, यहाँ पर हम कुछ ऐड नहीं किए हैं 6 and 8 को, क्योंकि 0 ही हैं, सिर्फ z चेंज हो गया. यहाँ पर भी आप दूसरा कुछ ऐड नहीं किए हैं, सिर्फ z कोऑर्डिनेट, नॉट z, y कोऑर्डिनेट चेंज हो गया. वी डिड नॉट मूव बिकॉज द लाइन इज ऑन द सेम. सो ये -3 and 4 सेम है, सिर्फ आपका y चेंज हो गया. But if you remember here in the third, you have to move a little bit this 2 and 2 point, then the 6 and 3. 3 को कुछ ऐड नहीं हुआ क्योंकि यहाँ पे 0 है. Fine. So these are the 3 problems which we have solved based on linear charge density. You can see it here. Previous problem में मैंने surface charge density का भी calculate किया है. Rho s divided by 2 epsilon naught. आपके क्वेश्चन में थर्ड मैंने स्क्रैच किया है. That you can calculate uniform surface density rho s. Rho s दिए हैं आपको, फॉर्मूला यूज करके सब्स्टिट्यूट करना है. दैट्स इट. फॉर्मूला इज E इक्वल्स टू रो एस बाई 2 एप्सिलॉन नॉट. रो एस आपको दिए हैं 57.2 divided by 2 epsilon naught is 1 free space. You will get some value of the field, but I've scratched it. You can substitute, no problem. Any doubts here? Okay, with this we have completed all the problems based on module 1. Any doubts you can ask me. So module 1 is completed. There is one problem, I'll be putting it in the Google Classroom. The solution I will put